Welcome to ENMU's pilot-scale dairy wastewater treatment facility called Algal Turf Scrubber, for short ATS. Developed in early 1980s, ATS is a solar-driven system that produces algal feedstock and simultaneously removes nutrients, emerging contaminants of concern from wastewater and impaired water as well. This is our carbon recovery unit. In this unit, we mix dairy wastewater with fresh water from an irrigation well to form the scrubber effluent. The resulting effluent is pumped to the trough. At the trough, houses of effluent are released, wash over the attached turf before draining back to the unit. We adapt algae cultivation to our local conditions for ultimate mass production of algal feedstock in the semi-arid Southwest. We also use algal technology to purify dairy wastewater in a cost-effective and environmentally sustainable manner. This is for wastewater reuse and for growing rural bioeconomy. Now you may wonder why we do this. As you know, New Mexico is ranked the #1 most water-stressed state in the U.S. Our water natural capital is threatened by surface and groundwater use, as well as climate warming. The Southwest U.S. is a hotspot of sensitivity to groundwater scarcity. And if you are interested in this project, join us at Eastern New Mexico University. We studied this project 7 years ago with support from National Science Foundation. The reason behind this project because on the east side of New Mexico, we have the dense New Mexico industrialized dairies. On a single day, 5.6 million gallons manure are generated in New Mexico, and the biggest cheese plant in North America, Southwest Cheese Plant, is about 15 miles to this location. We also have DFA plants nearby. The tremendous amount of wastewater make ENMU a natural research site to study how to convert the wastewater into green energy and a high-value product cost-effectively, environmentally sustainable. What do we do here? We transport dairy wastewater and then we dope that with fresh water in the carbon recovery unit. Then we recycle the wastewater so this 100 feet flowway. In about 1 week, we'll have algae fill the entire flowway. We do manual harvest and then bring them into laboratory using very simple chemical processes to convert lipids into biodiesel. And for the long run, we would like to find a way to make this system more mobile so that it can be deployed to dairy farms. In addition of using the traditional lagoon system for dairy wastewater management, we want this to be more effective, more environmental sustainable. Hopefully, the treated water can be reused for agriculture, for dairy operations. In the long run, we really want this to help grow our rural bioeconomy. In terms of how the system works, for instance, we pour dairy wastewater to the pond at this spot. Then that wastewater will diffuse into that corner where we have an immersion pump. An immersion pump sends effluent into the trough, and then we have the wastewater flows through the flowway and get returned at that terminal. So this is a recycling system. Here comes piles of effluent. When this wastewater flows through the system, nitrate, phosphorus, and other contaminants get removed by algae. Water get purified. Then algae we harvest, and then we try to analyze the composition, and we try to learn how to convert that into biodiesel.
Yeah, my name is Onukuli Chimeze. I'm from Nigeria. I'm studying master's degree program in chemistry here in ENMU. So here is our alga project site, and this is the pond where we receive the feed manual effluent, the waste from the dairy um, industries here in New Mexico. So we feed in the waste into this place, and then the treatment process starts. So this project is about production of alga feedstock from biomass. So we understand that the effluent made from the dairy industries can't just be released into the environment. So what we do is we get this effluent from the waste companies, and then we add it to this fresh water, and then alga is being generated. Now alga thrives in wastewater. So what we do is using the ATS technology that is developed in the 1980s, known as the alga top scrubber. Then we use it to generate this alga, and then it is harvested through this very novel technology. So, but my interest in this research project is the application of this alga. What is it? It spans through a lot. We talk of the application in the pharmaceutical industry. It could be used also as health supplement, and most importantly, as a source of biofuel. So this research, my interest in it is the knowledge I'm going to get in harvesting this alga and the things we can use it to achieve in terms of clean energy, and then of course waste recycling, such as getting clean water from here, will be of great interest to me in future, especially how we can use this alga to generate clean energy, biofuels, and then as nutritional supplement used in pharmaceuticals, and as well as even in cosmetic industry. So the application is very, very large. So that's the interest in this project. And going down there, it goes through the scrubber, and then down to this tubs here where we harvest the filamentous alga, and then go through other extraction processes to get what we want. So hopefully this project, I hope to go beyond the master's level and go up to a PhD level after this, and find out further ways we can make use of algae that we generate from this ATS technology for diverse future applications that gear towards clean energy friendly, that are environmental friendly, and how it impacts the pharmaceutical industry, healthcare industry. Thank you.
Hi, my name is Enrique Martinez, and I am a senior at Eastern New Mexico University. I am from Albuquerque, New Mexico, and this research site we are working on algae, how to convert algae into biofuels. How this can help me get a job, it gives me a better understanding on how to work more efficiently in the labs.
Hey, my name is Kaylin. I'm a senior here at ENMU. I'm standing in the local algae pond where we grow algae using wastewater from dairy farms. It's one of the most fun projects that I've worked on all my time here at ENMU. It's been really cool getting to spend time with other researchers, getting to see the way the algae grows. There's frogs here. We get to look at all the animals. It's really awesome. It's been a great experience. I hope that in the future that this experience will help me in graduate school, help me get my master's degree. I'm really looking forward to it. Thank you so much.
Hi, I'm Ashini Spillman. I'm from California, San Bernardino. I am a master's student for going to the chemistry program, getting a master's in chemistry. So in this research, what we're doing here is harvesting the algae, and we're going to extract the lipids for biofuel production. This filamentous algae here, looks like I'm gonna piss. Well, I tried. They're like really tiny. Anyways, this research is very helpful for if you want to go into environmental chemistry per se, and will help me get a job, providing the hands-on experience that I need, or if I want to work in laboratory environment with extractions of lipids.
Hi, my name is Trenton Crookshanks, and I'm a senior here at ENMU. I've been studying forensic chemistry for the past 3 years, and so while this project isn't necessarily my go-to, it has given me a lot of extra experience outside of laboratory classes. I've been able to see more into the future of science, and Eastern's helped me with that. As a recently accepted master's student, I believe that this project could be great for my thesis and for my future work in laboratories.